Okay, we're doing the in-class conservation momentum problem number 2. Here we have a raft and 2 swimmers jumping off of it. So everybody's at rest initially. And I'll call my swimmers little m and big M. And then the mass of the raft, mr. And that's the initial state. And at the end, everybody has a final, or the swimmers at least have a final speed of 2 meters per second. I'm going to call positive to the right, and that's going to be the direction that the big one jumps, just arbitrarily. And then we don't know what the velocity of the raft is. So we're going to do our if chart. The system here has to be all 3. Because if I include only 2 of those, like maybe just the 2 swimmers, then momentum will not be conserved because there'll be an external force, like from the raft exerted on the 2 swimmers, or whatever 2 of the 3 I choose, there'll be an external force from the third one, so momentum would not be conserved. So I'm making the assumption here that the water doesn't do anything significant. And right at the beginning of the motion, it's not too bad an approximation. Okay, so the little m swimmer is going to dive backwards 2 meters per second. So small mass. The big one is going to dive forward at the same speed, which means that there's more momentum on the top side than there was on the bottom. So the raft, which is much bigger, is going to have to go in the negative direction, which is to the left here, in the same direction the little swimmer is going. And because it's very big, we can tell that it's not going to go very fast. So we can tell all that just from the if chart. And we'll transcribe that into a conservation equation. Sum of momentum initial is sum of momentum final. Initially there was none, and at the end there's m Vm plus mv big M. Oops, that's a big M. Plus the mass of the raft, velocity of the raft. So we can solve pretty easily. The algebra is never the hard part on conservation momentum. It's the concepts, making sure you have everything in the right place, and analyzing the situation right, having a good if chart model, all that. Okay, so if I plug in those v's and everything, I'm going to get negative 0.5 meters per second. So that's in the direction of the lighter swimmer.